Hello everyone, I welcome you all to today's session wherein we will be continuing our discussion on the geometry, right. In the previous sessions we have taken up triangles, quadrilaterals to a small extent, right. So today we shall be taking up the concepts of particularly the quadrilaterals. We shall be looking at quadrilaterals and particularly some special type of problems. So again, just like any other class, in this class also when you see a question on the screen, pause and try out yourself that particular question for a while before we continue our discussion. I, however, in this class will be continuing with the discussion of the question, right. You can resume the video later on and try to match your answer with the option choices given here. Now have a look at this question, try to answer it. You can take around 5 minutes for this question, alright. You can pause and take around 5 minutes, see if you can crack it, and then resume watching the video. I would be discussing the question as I said normally. So let's get started with the information that we have here. So it says PQRS is a rectangle, as you see here, PQRS is a rectangle which is folded along the dotted line as shown. So this is the dotted line along which it is folded, such that the vertex R, this vertex, coincides with the vertex P. So when you fold it, R and P would coincide. If the length of the crease, dotted line, formed is equal to length of the rectangle. So if I take the length of the rectangle to be L, for example, so this is also the length L. So let's assume the breadth, the other side is breadth. So length and breadth, so that crease is also L, the length of the rectangle. Find the ratio of the length of the rectangle and breadth of the rectangle. So the final question is, we have to find length is to breadth is going to be how much. So let's try to think about ways to answer it, alright. So what kind of geometrical property should we make use of, alright, for answering this question. So what I would suggest is you also take a piece of paper. So here is the paper that I have. I would suggest you please have the paper yourself. Now this is a rectangle that we are talking about. So it's PQRS, the 4 vertices, just like that, PQRS, PQRS. Now what are we doing? We are folding this rectangle in such a way that these 2 vertices coincide. So this vertex and this vertex are coinciding. So let me also make them coincide. So I'll just try to show you how it would look, right, after the rectangle is folded. Now look at this. So this was the original rectangle, right. Now I am folding it. So the figure would appear as follows. So the figure would look like this, something like this. So this was the original rectangle. Now I am folding it. It would look like this. Now when I'll try to draw this particular folded figure, right, I'll try to draw it here and try to show you some details about this figure. So if you look at this figure, right, so it would be like this. Just a minute, I'm trying to have a rough diagram for this, alright. So this was a rectangle and this is how it is, alright. So this is how it would look, right. This is how it looks, right. Now let me try to draw some more dimensions to it. Now here, this was the overall length, right? This was the overall length. Now after I fold it, the length is going to reduce. This part is going to reduce by a bit. Now how much is it going to reduce by? Please notice. Now if I assume this length to be x, for example, let's say this is some AB. So if I talk about the length AQ, segment AQ, if I take it as x, this part is x. So if this part is x, can I say this part will be L minus x. So this part here is going to be L minus x after I fold it, right. Also notice one more thing. Now what is this length? This was nothing but the original breadth. So this dimension is becoming this hypotenuse here. So this is your breadth. Also, what is this length? Please notice what is this length? This is nothing but your x. When you fold it, there is nothing but your x. And can I say this triangle on the top, this one, is a right angle triangle. So this is your vertex P, that R is also coinciding with it. Alright. Now this Q comes here. This is your vertex A, this is your vertex B, and this is your S. Now this is a right angle triangle, correct? This is a right angle triangle. I hope you all agree because it's a rectangle, so it would be 90 degree. Now in this right angle triangle, we can apply the Pythagoras theorem. Let's apply that first. So first thing to know in this problem is, how do I visualize the diagram? And unless you have a figure like this in front of you, a small piece of paper, you won't be able to visualize this, that this x is going to be that x. This B is going to be this breadth here. It would be slightly difficult to visualize yourself without such a piece of paper. So I would advise making use of this paper, and in your exam also you would get a piece of paper, your hall ticket, your admit card, if nothing else, alright. You can just fold it again, unfold it and give it back, because you'll have to submit it at the end of the test. Now when you apply Pythagoras theorem on this, let's see what do we get. So I'll just change the figure. So here if I apply Pythagoras, this is your hypotenuse. So L minus x the whole square will be equal to what? B square plus x square. Now this can be simplified, right? This can be simplified as what? This will be L square plus x square minus 2lx, b square plus x square. X square can be cancelled out, and I will get the value of 2lx. I'll take it on the right hand side as L square minus b square. So I get 2lx as L square minus b square. I note it somewhere. I just clean this part again, alright. I'm just cleaning this. You can note it down if you want to. So okay, we get one relation between L and B in terms of x, L, B and x. Now let's go back to this diagram, original diagram. Also notice, after you fold it like this, so right, if you unfold it again, now this diagram I am unfolding it like this, right. So it would again back to the original rectangle, right. Now in this original rectangle, please notice the following. So from vertex A, let's say I am dropping a perpendicular. Let's say this is some C, vertex C. Now can we say if this is x, this is also going to be x. All right, say rectangle, opposite sides will be equal, x, x. Not just that, please also notice one more thing. If you look at this triangle which is formed on the top, this one, also please look at this triangle which is formed here. This triangle which is formed here, right? This one, this small triangle, which we are not able to see here, it would be something like this. Now there would be identical triangles. Now how can we prove them to be identical? Please understand, if I take this as some y, this is still going to be b, alright. Also, what is this length going to be, this folded length? It's going to be your L minus y. It's going to be your L minus y. So here also we can apply Pythagoras theorem and see L minus y whole square will be equal to b square plus y square. Now this is very similar to your previous equation that we had. L minus x whole square is equal to b square plus x square. So by direct comparison we may say that x should be equal to y. So thus I said these two triangles are identical. So this is also going to be x. So if this is x, this is going to be L minus x. Okay, so in fact we can just clean this. Let's clean this, no need to have a look at it. This is your x. So that is x. Here SB is also going to be x. Correct. Now later. Now look at the triangle ABC. Triangle ABC is another right angle triangle if you notice. Now in this right angle triangle, this length is given to be as L only, length of the rectangle. Now what is this length? It is B. And please note, what is this BC? BC is nothing but overall length minus 2x. And please also note, triangle ACB is also a right angle triangle. That means we can again apply Pythagoras theorem on that. So triangle ABC, it's a right angle triangle. When you apply Pythagoras there, you will get L square, hypotenuse square, is equal to L minus 2x whole square plus b square. So this is your L square, this is L square plus 4x square minus 4lx plus b square, separate. Now L square can be cancelled out. Now if I send this 4lx on the other side, so 4lx will be equal to 4x square plus b square. Now how do I get rid of this 4lx? We can get it off that 4lx using that equation L square minus b square, right? So what is L square minus b square 4lx going to be? It's going to be twice of this. So 2 into L square minus b square is 4x square plus b square. Let's try to get rid of this x also. Let's try to eliminate this x. Now what is x? L square minus b square by 2l. So let's replace that. So it's going to be 2l square minus 3b square will be equal to, so what is 2x from this? 2x is nothing but L square minus b square by L. So what is 4x square? It's square of this. So it's going to be L square minus b square whole square by L square. I hope we are able to follow this step. L square minus b square whole square by L square will be equal to 2x whole square, which is 4x square. So this way we get rid of x. So when you simplify, cross multiply and simplify, 2l square into L square, 2l power 4 minus 3l square b square will be equal to what? L power 4 plus b power 4 minus 2l square b square. Let's bring all terms on one side. Let's continue on other slide. You can just make a note of that. I am going to clean this. I just need to solve this equation now to find L is to b. So I'll clean this all. See, this kind of questions when they come in your CAT examination, it would become extremely difficult for even intelligent students to solve this. It's not an easy question. Now, as I said, point number 1 is you cannot visualize in your head, you need a piece of paper. Point number 2 is, alright, now you deal with 4th degree equations, L power 4, B power 4, which generally students tend to avoid. Quadratic is okay, but 4th degree becomes little bit difficult. Let's see how do we solve it. So 2l power 4 minus L power 4 is L power 4 minus B power 4 minus 3l square B square plus 2l square B square is minus L square B square will be equal to 0. Now what do we want to find out? We want to find out L is to B. If you look at the question, originally the question was we had to find the ratio of length of the rectangle and breadth of the rectangle. We have to find L is to B. So what we'll do for that is, let us simply divide this entire equation by b power 4. So when I divide by b power 4, what do I get? L power 4 by b power 4 minus L square by b square minus 1. Now let's do one more thing. Let us put L square by b square as some x, or let's not take x, let's take p, because x is already taken in our today's problem, x variable. So if I take it as p, so what will this become? This will be p square minus p minus 1 equal to 0. It's a regular quadratic. Now how do we solve it? We can use a formula because factorizing it is not an option. You cannot really factorize this. So let's use the formula for this. So when I use the formula, p will be equal to what? Minus b plus or minus root over b square minus 4ac upon 2a. I hope you all remember the formula. The formula for finding the roots is, I'll just write it down and clean it. For the equation ax square plus bx plus c equal to 0, the roots are minus b plus or minus root over b square minus 4ac upon 2a. Upon 2a. This is the formula that we have, right? I hope you know it, otherwise please note it down. So this will give you what? This is 1 minus of minus plus 1 plus or minus root over, this is 1 plus 4, 5 by 2. Now please note, I intentionally avoided 1 minus. Now why? Because 1 minus root 5 will give you a negative answer. And when you talk about the ratio of length and breadth, p is by the way square, it can never be negative. So So there is no need of taking minus, it is only plus. So 1 plus root 5 by 2 is P. Now what is P? L square by B square is 1 plus root 5 by 2. Hence can I say L by B will be nothing but square root of this. So we take square root of this. It's going to be square root of root 5 plus 1 is to square root of 2. So length is to breadth will obtain it as this value, alright. Let us not try to find the value of that. Let us look at the option choices. So square root of root 5 plus 1, I will just clean everything else, that is the answer. Okay, so that is the answer. Let us verify which one will. So square root of root 5 plus 1, okay, this is the one. Square root of square root 5 plus 1 is to square root 2. That is going to be our answer. And please look at the way in which options are written. Now square root means this simple. Square root 5 plus 1. So this question was difficult at multiple levels, alright. It was not at all an easy problem, alright. So in case you were not able to solve it in the 5 minutes that you tried, nothing to worry about, because most of the students will not be able to solve this question, right? Because it's not that easy. You would have seen it in our discussion today, right? But this is how we could actually get to the answer. It will take some time, but definitely solvable. So I thought of bringing out this question from quadrilaterals in front of you, because this will test us, alright. This will impart us knowledge on the visualization aspect of the geometry, alright, which is generally neglected, right? Students don't really, they just worry about mugging up the formula and all, but in this problem, formula alone were not going to help you. You need to have the right kind of visualization to crack this particular problem. I hope you have followed this. Now, there is one more problem that I have for you, right? Again, you can pause your screen, right? So this is like that problem which would give us some kind of confidence. You should be in a position to answer it, alright. Please try it out. Pause the screen for 2-3 minutes, try it out, and then you can resume the video. Let us discuss it here anyways. So the question says there is a park in the shape of a rhombus. So rhombus is a parallelogram where all sides are equal. It looks like this. One of the sides is 5 units. So if one of the sides is 5, all sides are 5. There are 2 gates exactly at the midpoint of 2 adjacent walls of the park. So this is one gate, let us say this is gate 1, midpoint of the wall, gate 2, okay, 2 adjacent walls of the park. There is a straight path connecting 2 gates, the straight path, like this, which is 4 units in length. So this is 4. The side is 5, this is 4. Find the area of the park. So first thing that we need to understand is, what is area of a rhombus? It is half product of diagonals, d1, d2. d1, d2 are the 2 lengths of the diagonals. Half product of the diagonals will be the area. Now how do we find the diagonal lengths here? It won't be very difficult. Please try to understand how. Now if you look at the, let us give them some names. This is vertex A, B, C, D. This is gate 1, gate 2, G1, G2, alright. Let us connect this AC diagonal. Let us connect this AC diagonal. Okay. Now if you look at the triangle ABC, I will just orient it right by 90 degree. This is how it looks, B, C, A, okay, and this is your G1, this is your G2, you are connecting them, this is 4. These are the midpoints. Now midpoints would mean the ratios are equal, 1:1, 1:1, okay. Now can I say the triangles B, G2, G1, B, G2, G1, this triangle, and triangle BCA, these 2 triangles can be proved to be similar. How do we prove it to be similar? We could use SAS property. Now what is SAS property? The ratio of BG2, this side, to BC, 1:2. BC is 2 units, BG2 is 1 unit, is same as BG1 by BA, this is 1 unit, this is 2 units. So side and side, two sides have same ratio. And also look at it, the included angle, angle B in the smaller triangle is same as angle B in the larger triangle. So by SAS we can prove them to be similar. Now if they are similar, can I say ratio of the sides will be equal? So that means G to G1 by CA should also be same as this. And what is BG2 by BC? It's 1 by 2. Now what is G to G1? It's 4. So 4 by CA, it's 1 by 2, you will get the length of CA. So CA will be 4 into 2 is 8. So this way you get the length of the diagonal, one of the diagonals is 8. So CA we get it as 8. You can just copy this, I am going to clean this. So this is 8, one of the diagonals is 8, CA is 8, I will write it somewhere. Okay. Now please notice, I will draw the rhombus again. This is your ABCD. Consider this to be the rhombus. This is your G1, G2, etc. You got this length, this is 8, AC is 8. Now when you draw both the diagonals like this, we know that in rhombus diagonals bisect each other perpendicularly. So that means this point here, if I call it as point P, if this entire thing is 8, this is going to be 4. This is 8, this midpoint is going to be, AP is going to be 4. Now we don't know what BD is, let us say this is some, PD is X, PD is X, and AD, the side length is given to be 5. And I just now said diagonals bisect each other perpendicularly, so that means this will be 90 degree. We can apply Pythagoras theorem, so AD square will be equal to AP square plus PD square. So when you solve this, you will get the value of X as 3. Now if this X is 3, overall BD length will be, the other diagonal is going to be 6. So this way I am getting both the diagonals. Now once I get both the diagonals, what is area of the rhombus? So half into product of the two diagonals, 8 into 6 is 48. So 48 by 2 shall give us the answer as 24 square units. So my answer is going to be simply 24 for this question. So this question number 2 for today's session, was a relatively easier problem as compared to the previous one. So I won't call this as difficult. This is easy to moderate level question, right? But the previous one was definitely a difficult or very difficult question. But I hope you have followed both the questions today, right? So that's it. These were the 2 questions that I had for you in today's session. So with this we have come to the end of the video, but before I conclude, would like to end the session by letting you all know that we are running this series of videos wherein we upload videos from both concept as well as specific questions, so right, questions of CAT level difficulty. I would suggest you to subscribe to our channel, right, so that you get notification whenever we release videos on the quant and verbal and other such topics, DI for example, right. Please interact, please be interactive, right. Some of you are doing that, right, wherever possible I am myself commenting on the videos, right, or someone from my team is trying to comment, and I see some really valuable suggestions coming in. So please keep that pouring in, right. Please do interact with us, do let us know what you want, right, so that we can modulate our lecture accordingly. Right. Thank you and all the very best.